Average acceleration. The average acceleration vector between Ti and T final is A average vector equal V final vector minus V initial vector over T final minus T initial, where T final minus T initial is the delta T, the duration of the motion. The algebraic value of the average acceleration is A average equal V final minus V initial over T final minus T initial, where V final and V initial are the algebraic values of V final vector and Vi vector respectively. The A average is expressed in meter per second square, which is the SI unit of the acceleration. Application 7. The two following questions are independent. Part 1. A car moving in a certain direction has a speed of 2 meters per second. So V initial, part 1, V initial equal 2 meters per second at a certain instant. Calculate the speed of the car 5 seconds later. So V final, it's unknown to be calculated. After of the car 5 seconds later, so delta T, it's the duration, it's 5 seconds later. If it accelerates with an average acceleration of 3 meters per second square, so A average equal 3 meters per second square during these 5 seconds. So we have A average equal V final minus V initial over T final minus T initial, it's delta T, the duration. A average is equal to 3 meters per second square. V final to be calculated. V initial minus 2 over delta T, it's 5. So by cross multiplication, 3 times 5, it's equal to 15, equal V final minus 2. Then V final, it's equal to 15 plus 2 equals 17 meters per second. Part 2. An aircraft travels at a constant acceleration of magnitude 8 meters per second square. So A average, it's equal to 8 meters per second square. At an instant T, the speed of the aircraft is 396 km per hour. So V initial, it's equal 396 km per hour. We must to convert to meter per second, divide by 3.6, it's equal to 110 meters per second. The aircraft breaks the sound barrier when its speed becomes 1224 km per hour. So V final, it's equal to 1224 km per hour. It must be converted to meter per second, divided by 3.6, it's equal to 340 meters per second. Calculate the time needed by this aircraft to break the sound barrier. We have, so delta T, it's unknown to be calculated, it's the duration. So A average equal V final minus V initial over delta T. A average, it's equal to 8, V final 340 minus V initial 110 over delta T. So cross multiplication, delta T, it's equal to 230 over 8, then delta T, it's equal to 28.75 seconds. Instantaneous acceleration. The instantaneous acceleration of a moving object is the acceleration at an instant t. For example, A2, it's equal A average 1 is 3. After 2, it's 3, and before 2, it's 1. So it's equal to V3 minus V1 over T3 minus T1, that it's equal to 2 tau. V1 and V3 are the algebraic values of the velocity at the instants T1 and T3 respectively. So T3 minus T1 equal T, it's equal to tau, is the time interval between the instants T1 and T3. For example, if we have calculated the instantaneous acceleration a3, it's equal to v4, the velocity after 3, minus v2, the velocity before 2 over 2 tau. a4, it's equal to v5, the velocity after 4, minus v3, the velocity before 4, over 2 tau, etc. Nature of rectilinear motion. If a vector and v vector have the same direction at an instant t, then the motion is accelerated at this instant. Like this, a vector and v vector have the same direction. While if a vector and v vector have the opposite direction at an instant t, like this, a vector and v vector have an opposite direction, then the motion is decelerated at this instant. Application 8. A particle A is in rectilinear motion along the x-axis. The adjacent figure shows some successive position of A where each two consecutive positions are separated by a constant time interval tau equal 40 milliseconds. So that tau is equal to 40 milliseconds. From millisecond to second times 10 to the power minus 3, it's equal to 0.04 seconds. The algebraic values of the velocities v1 vector, v2 vector, and v3 vector at t1, t2, and t3 respectively are v1, it's equal to 3.5 meter per second, v2 equal 2.5 meter per second, and v3 equal 1.5 meter per second. Part 1. Calculate the algebraic value of the acceleration vector a2 at the instant t2. a2 equal v3 minus v1 over 2 tau. So it's equal to 1.5 minus 3.5 over 2 tau, 2 times 40 times 10 to the power minus 3. It's equal to minus 25 meter per second square. This A2. Part 2. Write the expression of A2 vector. A2 vector, it's equal to minus 2, 5I vector in meter per second square. Part 3. Represent on the figure the acceleration vector A2. Drawing scale 1 cm correspond to 10 meter per second square. 1 cm correspond to 10 meter per second square. The value of the acceleration, absolute value, is it's equal to 25 meter per second square. We must to calculate the length of this acceleration to represent it. So L equal to 25 times 1 over 10. It's equal to 2.5 centimeter. So we draw a vector opposite direction than x-axis from point A2 2.5 centimeter. So this is A2. Part B. The velocity vector v2 drawing scale 1 centimeter correspond to 1.25 meter per second. So 1 centimeter is correspond to 1.25 meter per second. The velocity v2 is equal to 2.5 v2. So 2.5 meter per second below 1.25 meter per second, and we must calculate the length of its velocity. So L it's equal to 2.5 times 1 over 1.25. It's equal to 2 cm. Then from A2, the velocity vector v2, it's represent along the motion and with the motion, with the direction of the motion. Then to the right, we draw a vector from A2 to the right and equal to 2 centimeter. This is v2 vector. Now Part 4. The average speed between 0 and 160 milliseconds is 2.5 meter per second. So V average it's equal to 2.5 meter per second, and T final it's equal to 160 millisecond. From millisecond to second times 10 to the power minus 3, it's equal to 0.16 second, and T initial it's equal to 0 second. The abscissa of A is minus 16 cm at T0 equals 0. So X initial it's equal minus 16 centimeter. From centimeter to meter times 10 to the power minus 2, it's equal to minus 0.16 meter. Determine the abscissa of A at T equal 160 millisecond. So we must calculate X final. We have the average it's equal to X final minus X initial over T final minus T initial. The average is equal to 2.5. X final is to be determined minus X initial equal minus 0.16 meter over T final. It's 0.16 minus T initial, it's 0. So crisscross, we obtain 2.5 times 0.16 equal X final plus 0.16 equal 0.4 equal X final plus 0.16. Then X final equals 0.4 minus 0.16 equal to 0.24 meter. It's equal to 24 centimeter. From meter to centimeter times 10 power 2. Exercise 1. The following questions are independent. A body moves along a straight line with a speed of 30 meters per second in the positive direction. Write the expression of its velocity vector. Positive direction means V vector equal plus VI. So V vector equal plus 30 I vector in meter per second. Part B. The velocity of a body at an instant t is V vector equal minus 10 I vector meter per second. Indicate the value of the speed of the body at this instant. The magnitude of the velocity is equal to 10 meter per second. And specify whether it moves in the positive or in the negative direction. When the V vector equal minus 10I, then it moves in the negative direction. It moves in the negative direction. Part C. The position vector of a particle at an instant t is r vector equal minus 3I meter. Is this particle necessarily moving in the negative direction? Justify your answer. First, give an example. This x-axis and this is the origin O. This is the motion, this A0, and this A1, this A2, etc. So, to represent R1, it's equal to OA1, for example. Then, this is from O to A1, this is R1. In this case, R1 is equal, for example, minus 3I meter in meter. while the motion is in the positive direction, since A0, A1, A2 along x-axis with the motion of x-axis. So no, since the position vector is independent of the motion of body. This is so important. So part D, specify the nature accelerated or decelerated in the direction of each of the motion in figure A and B. In figure A vector and V vector have the same direction. So it's accelerated since A vector and V vector have the same direction. This motion is in positive or in negative direction. We must to compare the direction of V vector and the x-axis. In this case, V vector and x-axis have the same direction. So, in positive direction. Since V vector and x-axis have the same direction. Figure B now. Figure B. A vector and V vector have an opposite direction, so it's decelerated. Figure B, decelerated, since A vector and V vector have an opposite direction. In which direction? Positive direction or in negative direction? In this case, we must to compare the direction of V vector and x-axis. V vector is to the right and the x-axis to the left. So the direction of V vector and x-axis are opposite than in negative direction. Since V vector and x-axis have an opposite direction. Now part F. F. The acceleration vector of a particle at an instant t is a vector equal minus 2I meter per second square. Is the motion of this particle necessarily decelerated? Justify your answer. It's part E, it's not part F. No, it's not necessarily decelerated motion, since the motion of a particle opposite to x-axis then the V vector is opposite to x-axis, then v vector and a vector have the same direction, then accelerated. This is, for example, if the v vector is opposite to x-axis, then and a vector it's minus, so v vector and a vector have the same direction, then it's accelerated. Part F. In the adjacent figure, the velocity v2 at the instant t2 of a moving particle is drawn to scale 1 centimeter, correspond to 0.5 meter per second. Determine the characteristics of v2 and then write its expression. By a ruler, we measure the length of v2, the length of vector v2 in this figure. We obtain v2 length L of v2 is equal to 2 centimeter, so it's correspond to v2. v2 it's equal to 2 times 0.5 over 1 equal 4 centimeter. So the characteristics are the point of application, it's M2, direction to the right with the motion, line of action, it's horizontal, along x-axis, and magnitude it's equal to 1 meter per second. 1 meter per second, here meter per second. Exercise 2. The table below shows the position xt of the center of a book released on an inclined air table without initial speed, tau equal 20 milliseconds, from millisecond to seconds times 10 to the power minus 3 seconds. Part 1a. Draw a diagram that represents the records using 1 centimeter graph correspond to 2 centimeter. This is xt, xt in meter. This is the origin O, 0. Here 2. Here 4. Now 6. Each 1 centimeter correspond to 2 centimeter. 8. 10. 12. 14. 16. 18. 20. 22. 24. 26 and 28. A0 it's at point 0, so this is A0. A1 it's on the 7 centimeter, this is A1. A2 on 13, this is A2 A3 on 18 centimeter. This is A3. A4 on 22. This is A4. Locate A4 here. A5 at 25. So here A5. A6 27. Here A6. And finally A7 on 28. Part 1B, this is 1A, 1B. What is the type of trajectory justified? The type of trajectory here is rectilinear, since the positions are collinear. It's a straight line. Rectilinear, since the positions are collinear. That means straight line. 1C. What is the nature of motion justified? We observe that the distance between the positions is decreasing with time. So the motion is U, D, R, M. Since the distance between the positions decrease with time. What is the meaning of UDRM? Uniform decelerated rectilinear motion. So the motion is decelerated. So UDRM is uniform decelerated rectilinear motion. That means it's decelerated and the type of trajectory is rectilinear. So it's uniform decelerated rectilinear motion. Part 2, calculate the average speed between during the whole journey. So V average, it's equal total distance over delta t. So it's equal the total distance, it's OA7 over 7 tau. So it's equal to 28 times 10 to the power minus 2 from centimeter to meter times 10 to the power minus 2 over 7 times tau 20 milliseconds times 10 to the power minus 3. We obtain 2 milliseconds. Part 3. Calculate the instantaneous speed of the book T1, T2, T3, T5, and T6. So the instantaneous velocity, they are V1. It's equal to A0, A2 over 2 tau. So it's equal to OA2 minus OA0 over 2 tau. It's equal 13 minus 0 times 10 to the power minus 2 from centimeter to meter over 2 times 20 times 10 to the power minus 3. We obtain V1 equal 3.25 meter per second. So this is V1. V2, it's equal A1, A3, the distance between two A1 and A3, over 2 tau, so it's equal to OA3 minus OA1 over 2 tau. It's equal 18 minus 7 times 10 to the power minus 2 over 2 times 20 times 10 to the power minus 3. We obtain V2, it's equal to 2.75 meter per second. V3 equal A2 A4, 3 between 2 and 4, so A equal A2 A4 over 2 tau, it's equal to OA4 minus OA2 over 2 tau equal 22 minus 13 times 10 to the power minus 2 over 2 times 20 times 10 to the power minus 3. So we obtain V3 equal 2.25 meter per second. V4 equal A3A5 over 2 tau, it's equal to OA5 minus OA3 over 2 tau equal OA5 25 minus OA3 18 times 10 to the power minus 2 over 2 times 20 times 10 to the power minus 3. So V4 it's equal to 1.75 meter per second. V5 equal A4 A6 over 2 tau, it's equal OA6 minus OA4 over 2 tau equal 27 minus 22 times 10 to the power minus 2 over 2 times 20 times 10 to the power minus 3. It's equal to 1.25 meter per second. This is V5. So V5 equal 1.25 meter per second. Finally, V6 equal A5 A7 over 2 tau equal OA7 minus OA5 over 2 tau equal 28 minus 25 times 10 to the power minus 2 over 2 times 20 times 10 to the power minus 3. It's equal to 0.75 meter per second. So V6 equal to 0.75 meter per second. Part 4. Determine the acceleration of the book at T2, T3, T4 and T5. So A2 it's equal to V3 minus V1, the velocity just after 2 minus the velocity just before 2 over 2 tau. So equal 20.25 minus 3.25 over 2 times 20 times 10 to the power minus 3 equal minus 25 meter per second square. A3 equal V4, the velocity just after 3 minus V2, the velocity just before 3 over 2 tau equal 1.75 minus 2.75 over 2 times 20 times 10 to the power minus 3 equal minus 25 meter per second square. A4 equal V5 minus V3 over 2 tau equal 1.25 minus 2.25 over 2 times 20 times 10 to the power minus 3. It's equal to minus 25 meter per second square. And A5 equal V6 minus V4 over 2 tau equal 0.75 minus 1.75 over 2 times 20 times 10 to the power minus 3 equal minus 25 meter per second square. From part 3, we observe that the velocity it decreases with time. So V1 it's equal 3.25 meter per second, while V2 equal 2.75 meter per second, it's decreased, while V6 equals 0.75 meter per second. So the velocity it's decreases with time. And in part 4, we obtain A2, A3, A4, and A5. They are constant and they are negative value. So in this case, the motion is decelerated. Decelerated, that means the velocity decreases with time. And we conclude that the acceleration is negative in this case. Part 5. Write the vector position vector R3 and represent it on the diagram. 5. R3 by definition it's equal to OA3 vector. So it's equal to 18I vector. Characteristics of R3. Point of application. It's always the origin O. Direction from O to A3. Line of action is always along x-axis. And magnitude (18 centimeter). It's equal to the distance OA3. So for represent from O, we draw a vector till A3. This is R3. The position vector R3. Part 6. Write the velocity vector V4 and represent it on the diagram. Take 1 centimeter correspond to 1 meter per second. We have V4 it's equal to plus 1.75 I meter per second. This is the velocity vector V4. We represent V4 for 1 centimeter correspond to 1 meter per second. We have the V4 equal 1.75 meter per second. So the length it's equal L equal 1.75 centimeter. Before the representation of V4, we write the characteristics of V4. Point of application, it's A4. Direction, with the motion, with the direction. Of motion. Line of action along x-axis and magnitude V4 equal 1.75 meter per second. So we draw a vector from A4 to the right with the motion of length 1.75 centimeter. So this is V4 vector. Part 7. Write the acceleration vector A3 and represent it on the diagram. Take 1 centimeter correspond to 5 meter per second square. We have A3 vector equal to minus 25 I vector in meter per second square, since A3 equal minus 25. So A3 it's opposite to x-axis as direction, so to the left. Characteristics: A3, point of application, it's A3, direction, opposite to the motion, line of action, along x-axis, and magnitude 25 meter per second square. We use the scale 1 centimeter correspond to 5 meter per second square. The acceleration is 25 meter per second square. So L equal 25 times 1 over 5 equals 5 centimeter. So we draw the vector A3 from point A3 to the left by length of 5 centimeter. So this is A3 vector. We observe that the velocity vector and the acceleration vector has an opposite direction, so the motion is said to be decelerated. A. What is the type of motion? Is U, D, R, M, Y? Since first the distance between the positions decrease with time, and the velocity decrease with time. The acceleration is constant and negative, and the acceleration vector A vector and V vector have an opposite direction.